In lesson 2, we're going to look at polynomials and factoring them, as well as expanding. For some of the things we're going to be looking at collecting like terms, we're going to have to be able to do that using the distributive property, expanding second degree polynomials, and factoring quadratics when the number in front of the x squared term is 1. Now, all of this lesson should be review if you've taken grade 10 applied or academic math already. So first of all, let's review what is a polynomial anyway. Well, a polynomial is just an expression that has variables that have whole number exponents. And a whole number is a number that is positive and doesn't have any decimal or fraction or anything like that. So let's look at these three examples on the left here and consider which of these three is a polynomial. And the first one, which is 5x cubed, is that a polynomial? Well, yes it is. So why? Well, if you look at the exponent, we have an exponent of 3 here, and that 3 is a whole number. It's a number that's positive. It's not a decimal or a fraction, so 5x cubed is a polynomial. So 3 is a whole number. In our second example here, we've got negative 2x to the power of negative 1. Is this a polynomial? No, because negative 1 is not a whole number. Okay, negative 1 is an integer, not a whole number. And lastly, we have 7 over y squared. Now, at first glance, this one looks like it's probably a polynomial because this y is squared to the power of positive 2, but it's in the denominator. And so no, this is actually not a polynomial because this is the exact same thing as saying 7y to the power of negative 2. So negative 2 exponent means it's actually on the bottom. So this exponent is a negative, so it is not a whole number, and so this expression is not a polynomial. Now the degree of a polynomial is the degree of the term with the highest exponent. So we've got three terms here. We've got a 5x squared, a minus 2x, and a 7. So what's the degree of this polynomial? Well, the degree is equal to 2. Why? Because this exponent is a 2, this exponent is a 1, and this exponent is a 0. So the biggest out of those three exponent options is the 2, so the degree of this whole polynomial is 2. Now, if we look at the term, the part of the polynomial expression that has the largest degree, the number in front of that is called the leading coefficient. Now in this first example here, we're asked to expand 3 times x minus 4. And this is just the distributive property. So when we go 3 times x minus 4, what we're really doing is we can do the 3 times x and the 3 times minus 4. That's the distributive property. So 3 times x is what we're going to do first, and we're going to go 3 times negative 4 as well. 3 times x is just 3x, and 3 times negative 4 is negative 12. So 3 times x minus 4 is 3x minus 12. In the next example, we're asked what is to expand 2y times 3y plus 2. So what we're going to do is we're going to take, just like in the last example, we're going to take our 2y and we're going to use the distributive property on it. And that's how we're going to expand. So what we really have is a 2y times a 3y and a 2y times a positive 2. So 2y times 3y, that is going to be 2 times 3 is 6, and y times y is y squared. Remember, when you're multiplying with the same base, you can add your exponents. Each of these have an exponent of 1. 1 plus 1 is 2. And we have 2y times 2, so that's 4y. And that's actually as simple as we can make it, a 6y squared plus 4y. And that's what you get when you expand 2y times 3y plus 2. Now in this example, we don't have a monomial or something with one term times something with two terms. We have two terms times something with two terms. Okay, but we're actually going to do the exact same thing as before. So we're going to take this first part, the 2x, and we're going to have to use the distributive property on that. And then we're going to take the second part, the 4, and we're going to use the distributive property on that as well. Okay, so what we really have is a 2x times an x plus the 2x times the negative 3, and we have the 4 times the x, and we have the 4 times the negative 3. So each part of the first set of brackets is getting multiplied into each part of the second set of brackets. 2x times x is 2x squared. 2x times negative 3 is negative 6x. 4 times x is 4x. And 4 times negative 3 is negative 12. Now, you can see right here we've got two terms here that have just x as the variable. And those are like terms. And we can group those together. So we have 2x squared, a negative 6x, and a positive 4x, which totals out to a positive 2x. And we still have our minus 12. Okay, so this was the expanding part. We expanded to get this, and then we simplified by grouping our like terms. And here's our final answer. So 2x plus 4 times an x minus 3 equals 2x squared plus 2x minus 12. Okay. Now in the last example we were expanding, and now we're asked to factor. So to go, when we look at that last example again for a moment, to go from this form into this form is called, so from here to here is called expanding. And if we were to work our way back, so if we were given this form and we were to go back to this form, that would be called factoring. We'd be coming back this way. And that's what we're asked to do in this next example. Now for this example, the two parts we're going to look at is this negative 8 and this positive 15. And we need to consider what two numbers multiply to give us positive 15 and what two numbers add to give us negative 8. And they must be the same pair of numbers. And we always want to start with this 15. So how can we multiply to get a 15? Well, we can go 1 times 15, and we can go 3 times 5. Those are the two ways that we can get to positive 15, right? So 1 times 15 is 15, and 3 times 5 is 15. They both work out. Now which combination of these get us to negative 8? Well, let's consider it. What is 1 plus 15? Well, that's 16. That's not negative 8, so that won't work. What's 3 plus 5? Well, that's positive 8, so it's close, but we need negative 8, so that won't work either. Okay, so what other ways can we multiply to give us a positive 15? Well, we can go negative 1 times negative 15. That would be positive 15. Or we could go negative 3 times negative 5. That would give us positive 15 as well, because a negative times a negative is positive. So what happens when we add these things together? Well, negative 1 plus negative 15, that gives us negative 16. That's not negative 8, so that's not the one we want. And negative 3 plus negative 5, that is negative 8. So negative 3 and negative 5 work for both of these. So negative 3 times negative 5 is 15, and negative 3 plus negative 5 is negative 8. Okay, as soon as we have those two numbers, we know that x squared minus 8x plus 15 is equal to, when we're factoring, so we're going to end up with two sets of brackets. The thing that goes in the first part of the brackets is x, and then the two numbers we come up with go into the second parts. And it doesn't matter which one goes in which bracket. We could have the negative 5 here and the negative 3 here. It doesn't really matter. We get the same answer. Now just to show that this is the right answer, this is this polynomial factored. Let's use the distributive property on this and see if we end up with the exact same answer, exact same thing that we started with. Okay, you don't have to do this in the questions. This is as far as they want us to go. But I'm just checking my answer this way. So x times an x is x squared. X times a negative 5 is a negative 5x. And then we do the same thing with the negative 3. So negative 3 times the x is negative 3x, and negative 3 times negative 5 is positive 15. And when you group your two like terms together, the negative 5x and the negative 3x, we end up with x squared minus 8x plus 15. Okay, so you can see how going from this to this is factored form, and then expanding is just working our way right back to where we started. In the last example, we're asked to factor x squared plus 3x minus 10. Okay, so again, we care about these two numbers right here, the positive 3 and the negative 10. What multiplies to give us negative 10? It's always the last part. And what two same numbers add to give us positive 3? And you always want to start by thinking about what multiplies to give negative 10. And we've got, I think, 4 options. We can go negative 1 times 10. We can go 1 times negative 10. We can go negative 2 times 5. And we can go 2 times negative 5. These 4 combinations will get us to negative 10 by multiplying. Now, which combination, when we add them up, will we get 3 as our answer? Well, 1 plus 10 is going to be 9, so that doesn't work. 1 plus negative 10 is negative 9. That doesn't work. Negative 2 plus 5 gives us 3. Oh, this one works. And just to show you that this one wouldn't work, 2 plus negative 5 is negative 3, but we were looking for a positive 3, so that one doesn't work either. This is the one that works, so negative 2 times 5 is negative 10, and negative 2 plus 5 is 3. So we set up our two sets of brackets. The x goes first, or whatever letter is right here, and then one is a negative 2, and the other one's a positive 5. And there we go. We have factored this expression right here.